Welcome to the lecture. My name is Sonain Jamil, and today we will discuss what is frequency sampling design method to design an AFIR filter. The key feature of frequency sampling is that filter coefficient can easily be calculated based on the specific magnitudes of the desired filter frequency responses uniformly in frequency domain. So it is it has design flexibility. If we recall what we have studied in past is that this is the formula of inverse discrete Fourier transform that we discussed in detail by circles and everything, where W of n. Then we discussed a method that is called radix 2 method, FFT, fast Fourier transform. Then we discussed this W, and I have given you the idea that this exponential can be written in the form of sine and cos by using Euler identities. So, figure of the filter, the maximum frequency in a filter is pi. Whenever we talk about the maximum frequency in a filter, uh, then it comes out to be pi. Then after pi, the replicas are produced. So that sigma naught, sigma 1 are normalized frequencies, and h of k is the magnitude of the filter coefficients. So what is the procedure of designing a filter through frequency sampling method? First of all, we will have to calculate sigma k. Sigma k by using this formula. Sigma k is the normalized frequency. First of all, we are given the length of the filter that we will be asked to design a 5 tab filter, 7 tab filter, 3 tab filter, whatever the specification is given. We will calculate m from that, substitute in the formula, and then we will calculate sigma k, normalized frequency, that varies from 0 to pi, because the maximum frequency in a filter digital domain is always pi. Then we will calculate h of k. When sigma k is calculated, then we will calculate h of k, and k varies from 0 to m. M will be calculated from n is equal to number of tab is equal to 2m plus 1. Length of filter is equal to 2m plus 1. So from that we will calculate m. Then we will calculate the filter coefficients by using this long formula 1 over 2m plus 1 h naught plus 2 sigma k is equal to 1 to m, and h of k cos 2 pi k n minus m 2m plus 1. Now what is m? M varies from 0 to m, and as we talked that in the previous lecture, there is a symmetry about origin. So this is the origin response at origin, and all these are the symmetrical responses. So this is multiplied by 2. We can then we will have to use the symmetry, as I told you, to determine the rest of the coefficient. Let's have an example. We are asked to design a linear low pass filter with 7 taps. The length of the filter is 7 taps. Cutoff frequency of the filter is given 0.3 pi radian. Using the frequency sampling method, we'll have to design a filter. First of all, we'll have to calculate M. From M, we will calculate sigma k by using the following formula: 2 pi k over 2m plus 1. So just substituting the value of 2m plus 1, 7, and varying the values of k, we will get sigma 0, that is 0 radian, sigma 1, 2 pi by 7, sigma 2, 4 pi by 7, sigma 3, 6 pi by 7. Then normalize cutoff frequency is given, which is 0.3 pi. So is this sigma 0 less than 0.35? Because we are going to design a low pass filter, so there should be the frequencies that are less than this 0.3 pi. As this 0 is less than 0.35, so we will assign h of 0 to 1. Then if we divide 2 by 7, then it will come out to be 0.2 something. It is again less than 0.3, it will be assigned 1. If we divide 4 by 7, it will come out to be 0.4 something. Then all these frequencies are 0. As we have completed the first step, the next step is calculate the FIF or filter coefficient. Just we will have to substitute the values in the formula. This formula, because the length M is 3 from the length of the filter, so just substituting the values and varying the value of N, we will get the filter coefficients. Then again, using the symmetry, we will calculate the other coefficients. So that's it for today's lecture. Thank you very much for watching.